Hey guys, wanted to do a little video here today on the next part of scientific notation. We've done multiplying and dividing with scientific notation. Now we want to do adding and subtracting. Now just to be honest, this is probably the lesser of the two. Multiplying and dividing is much more important than this. And I forgot my camera tripod at home, so I'm going to have to just hold my phone here. Sorry if it's a little bit shaky. But with adding and subtracting, here are the rules we want to kind of go over today. Before you can add and subtract anything, your exponents have to match. The exponents have to be the same before you can do any adding and subtracting. We're going to talk about that here in a second. So what you'll do is you'll have to change the exponents to get them to match. If one is a 5 and the other is a 4, you'll have to either move the 4 up to a 5 or you have to move the 5 down to a 4. But it really doesn't matter. But you've got to pick to do one of those. And so if you decide to make one exponent bigger, that means the decimal that's right in front of it has got to get smaller. Or if you decide to make the exponent smaller, you're going to take the decimal that's in front of it and make it bigger. So it's almost like for one you make it bigger, the other one you make it smaller. If you make the first one smaller, you make the other one bigger, just to kind of balance it out. So let me show you what I'm talking about, because just seeing it on a board doesn't really make a lot of sense. Now look at this question, right? Now, if I really wanted to, could I add these like normal? Could I take this decimal and move the decimal place 4 times to the right? I mean, I could 1, 2, 3, 4, and put in the zeros and get 68,900. I could. And over here, could I do 9.24 and move the decimal 5 places and go 1, 2, 3, 4, 5 and get 924,000? And then could I add those two together on my calculator or just working it out by hand? And then could I write that answer in scientific notation? You could. But think about how much work that is, right? I'd have to take 924,000 and 68,900. I'd have to line it up like this, and then I'd have to add them up. Look how much time this is taking, guys, right? And for some people, they might think this is easy. And I mean, it's not hard, is it? So this is my answer, but it's not in scientific notation. So then I would have to, you remember, we'd have to put the decimal in there, and you have to move the decimal back. This is the long way to do it. Now, if this is the only way you know, I'm not going to hate on you if this is the way you have to do it, but look how much, this took a long time. 1, 2, 3, 4, 5. So, I mean, I got the answer, but look, I had to take each number, I wrote it in standard form, then I added them, I had to line it up, and then I moved the decimals. That takes a long time. And what if they gave us one that had like 10 to the 10th or 10 to the 15th? Would you want to put all those zeros? You probably wouldn't. So remember that answer, 9.929 times 10 to the 5th. But let me show you a different way to do it. Okay, so the faster way to do it, the way that I want to show you today, is we want to add these up going a little bit quicker. So you've got two choices. These are different exponents, right? One is to the 4th power, one is to the 5th power. Apologize about the bell there. So you can either make this bump up and make it a 5, or you can take this one and drop it down and make it a 4. It honestly doesn't matter. You can get the answer the same both ways. I kind of like to make this one, take the one that's smaller and make it bigger. So if I just decide to bump this up and make it 10 to the 5th, if you make this bigger, you've got to make this smaller. Right? Now, how much smaller? Well, look, we moved this exponent up 1, right? We added 1. We bumped it up 1 spot, so it would match this one, right? We wanted our 4 to be the same as this, so they were both a 5. So if I move this up by 1, guess what you're going to do to this one? You're going to move the decimal back 1 place. So instead of 6.89, you're going to take this number and make it smaller. You're going to make it 0.689. Now, technically, this is not legal scientific notation, right? Because this number isn't in between 1 and 10. But look what you get. You get this one that's 10 to the 5th, and this one was already 10 to the 5th. All right, see how now I have both of them as 10 to the 5th? I'm just going to copy this one down again. You really don't have to. Now that they're both 10 to the 5th, now 10 to the 5th here, 10 to the 5th here, now I can add them up, right? So remember, line up your decimal points. 0.689 is the first one. You can put a 0 in front of it if you want. The second one is 9.24. And in that little empty spot here, you can put a 0. And now I can add it up. I know my answer is going to be 10 to the 5th because that's what I spent all that time trying to get them to be the same. So I know it's going to be something times 10 to the 5th. I just need to figure out right here what this decimal is going to be. And this is where you can just add it up. 9 plus 0, 8 plus 4, carry the 1. That's 8 plus 1 is 9. And then 0 plus 9. And so here it is, 9.929 times 10 to the 5th. Always, always, always do a little double check. Is this legal? Is my decimal between 1 and 10? Yes. Do I have times 10 to a certain power? Yes. And so this is good. Okay? That's kind of weird though, isn't it? You had to decide. Do I want to make this 4 into a 5 to match with this one? Or let me show you the other way, just to be honest. I'll show you the other way you could have done it. Let me erase this real fast. Sorry, the camera's going to get a little weird. Okay, just to show you that I wasn't lying here, instead of taking the 4 and making the 4 bigger so it matches the 5, we could have taken this 5, we could have said, okay, instead of making them both 4s, or both 5s, let's make them both 4s. So if you wanted to, you could have said, you know what, I'm going to take this and drop it down by 1. I'm going to subtract 1 and make it 10 to the 4th. But because you made this smaller, you would have to make this, bigger. This would have to get bigger by 1. And so you'd have to move it 1 to the right to make the number bigger, and it would become 92.4, which is technically too big for scientific notation, right? This is the other way to do it. I don't personally like this one as much, just because you'll see what happens at the end here. It gives us one extra step of work, and I don't know about you, but I'd rather do less work than more work. But if this is the way you understand it, go ahead. See how now they're 10 to the 4th? So I know my answer is going to be something, 10 to the 4th, but I'm going to add the decimals. 6.89, 92.4. Remember from like 5th and 6th grade math, you got to line up the decimal points. See how the decimal points are lined up? You can fill these empty kind of spots with zeros if you want to. And then you can add them up. Here's the reason I don't like this one as much. Look what happens whenever we add this up. Now this one we know it's got to be 10 to the 4th because I chose to make both of them 4s. Look at this. Is this correct scientific notation? 99.29 times 10 to the 4th? This is not good enough, is it? Frowny face, right? This number is too big. Remember, our rule for scientific notation is this number has to be in between 1 and 9.99999, right? In between 1 and 10. And so this is too big. And so this is why I don't like doing it this way sometimes, because you've got to take this extra step. Since this number was too big, we got to move the decimal back. And if we made this number smaller, we got to make this number bigger by 1 spot and make it 10 to the 5th. And that's the answer we got on the other one. It's 2 ways to do it. You could either take the 4 and make it a 5, which is what I would have done first, or you could have taken the 5 and made it a 4. That's what we just did right here. But either way, we get the same answer. So actually, I showed you 3 ways to do that one problem. Let me show you another one. I'm not going to do it 3 ways because I think that sometimes confuses people. Okay, here's a different one. We've got a couple choices. We could take this 6 and bump it up and make it a 10, or you could take this 10 and drop it down to a 6. And I'm just going to be honest, I like to take the small one and make it bigger. So I'm going to take this small one, the 6, and we're going to magically just kind of make this 10 to the 10th. Now let's be real. How many did I have to add? If I'm going to bump this one up, I'm going to have to add 6 is where I'm starting. I want to get to 10. I'm going to have to add 4, aren't I? I'm going to move this up 4 places. So if I move this decimal, it's not a decimal. If I move this exponent bigger by 4, guess what's going to have to go to the decimal? The decimal is going to have to get smaller by 4. So I'm going to move this to the left 4 places. 1, 2, 3, 4. Now I've got all these empty spots, right? You all know what goes in these empty spots. 0, 0, 0. And so look at my new number now. 0, 0, 0, 8. Oh, geez, I'm out of room. Okay, let me erase that. I didn't give myself enough space. Let me go way over here. 0.000864 times 10 to the 10th, right? This and this, what I have in black, are the same thing. It's just a different way of writing it. It's like saying, hey, I have 100 cents or I have $1, right? The same amount of money. It's just different ways of writing it. And then over here, this is already 10 to the 10th. So I'm going to keep it the same. I'm not going to mess with that. All right, so now do you see how we have the same exponent, 10 to the 10th and 10 to the 10th? That's what you want. I can't do any adding or subtracting until I have these the same exponent, 10 to the 10th and 10 to the 10th. All right, and the way I did that, I took this and made it bigger by 4 places. And so since this went up by 4, this had to go down by 4, 1, 2, 3, 4, and I moved it back. Okay, now that they're both 10 to the 10th, I know my final answer is going to be something 10 to the 10th. That's going to be on my final answer. Now I just need to get the decimal part. I don't know what goes right here in the decimal spot. So the decimal spot is just adding this up. Holy cow, look at all these decimals. I don't think I gave myself enough room. 0.000864, and then this one is 1.334. Remember, the decimals have to be lined up. See how I did that? I kept the decimals lined up, and then all these empty spots are going to have zeros in them. So this is going to be a little bit awkward. My little box here is not going to be big enough. Sorry, let me erase it real fast. Sorry, I had to stare at the table. All right, so I'm going to add this up. In fact, I'm going to scoot that out of the way. Let me just go ahead and add this up here. 4 plus 0. 6 plus 0, 8 plus 0, 0 plus 4, 0 plus 3, 0 plus... This question came out of the book, guys. I didn't make this up. This is on the extra practice questions. But look, is this legal? Is this a decimal between 1 and 10? Yes, it's kind of a creepy looking decimal because look how many points it has, or decimal places. But it is in between 1 and 10, and so that's my right answer. Bingo. That was a hard one. Okay, now, subtracting. Same thing. Don't let it throw you off if it's subtracting. You've got 9.36 times 10 to the 5th minus 3.21 times 10 to the 3rd. My advice to you is to take, well, it really doesn't matter, but I like to do this. I like to take the smaller one and move it bigger, right? That's just my opinion. I just think it makes it easier at the end. So I want to make this 3, and I'm going to bump it up to a 5 because I need this and this to match. So I'm going to move this one up 2 places. 3 is going to become a 5. I just said so. I made up the rules. I said I'm going to move it up and make it a 5. If I move this up 2 places, I need to move the decimal back 2 places. So I need to make this smaller by 2 places. One goes up by 2, the other goes down by 2. And so back, 2 places. I'm going to put 1 0 right there, right? 1, 2. Those are my 2 places. So my new decimal is 0.0321, which is technically illegal, but that's okay. It's not the final answer yet. And now I'm just going to copy this first one down again. You really don't have to copy this down, but I just like to keep myself organized. Now do you see how they're both 10 to the 5th? 10 to the 5th here and 10 to the 5th here. Now it's okay to subtract it, right? I know my final answer is going to be something 10 to the 5th. I just need to figure out what decimal it's going to be. What decimal is going to go right there? Well, let's take my first one, 9.36. And let's take my second one, 0.0321. Keep the decimals lined up. Oh, geez. If you don't line up the decimals, this is where you're going to mess up. Okay, I'm really bad at this. I would definitely use a calculator to help me. So don't feel embarrassed if you want to use that calculator too, because I'm not very good at this. 59. How about this? 7, 2, 3, 9. I think that's right. This is a decimal between 1 and 10. I would definitely want to double check that on a calculator. This is in between 1 and 10. This is 10 to the 5th. This looks like a good answer, guys. Right? The hard part is at the beginning. Move this up by 2, move this back by 2. And then once you get them to both be the same exponent, then you can just add or subtract them like normal and definitely use a calculator, right? Especially on these subtracting ones. I do not like subtracting, especially when I have to do it by hand when there's zeros. That really hurts my brain. Use a calculator. That is fine, guys. I want you to use a calculator. That's why your parents got you one. Okay, the last one, and then I'll stop because this is almost 15 minutes long. When the book wants to be really, really rude, they will make you do an extra step. Because look, this one is in scientific notation and this one is not. That is very rude. And so if they give you one that's not in scientific notation, all you need to do, take just a few seconds and take the number that's not in scientific notation and put it in scientific notation, right? Remember, if there's no decimal, you put it at the back, and then you just have to move that decimal to the left until you land on a number between 1 and 10. Whoa! So here, I'm going to move it back. 2, 3, 4, 5. Do not stop right here. Some people get past the zeros and they think they're done. No. Look what I would be left with. I would be left with this, 24. Is 24 a number between 1 and 10? It is not. I'm going to go one more and make it 2.4. This is really 2.4 times 10 to the 1, 2, 3, 4, 5, 6. You know what? It might have actually made sense. It might have made sense to move it 5 places. Since this has a 5 on it, I probably could have moved it 5 places. But whatever. We're going to do it like normal. I'm not going to take a shortcut. That probably would have been a shortcut. So, step 1, put them both in scientific notation. Now, I have a problem though because they are not the same exponent. This is a 5, this is a 6. Here's our 5, here's our 6. I need them to be the same. So, I like to take the smaller one and make it bigger. So I'm going to take this 5 and I'm going to bump it up one spot to make it a 6. If I move this up 1, I need to take the decimal that goes along with it and move it down 1, right? Kind of balance it out. So this is going to go up by 1, this is going to go down by 1. So that means I'm going to move it back 1 place, and it's going to be 0.73, which is the same thing as 0.73 if you want to put a 0 in front of it. Okay, so that one is good. My green one over here has not changed. I'm just going to copy down the green one. Do you see how now they're both 10 to the 6th? This is 10 to the 6th, this is 10 to the 6th. So now I can get ready for my final answer. I know that I'm going to have 10 to the 6th as my last part. I just need to figure out what decimal goes here. All right? And that's where my 0.73 and 2.4 line up the decimal points, right? They have to be lined up, straight up and down. If you have one decimal here and one decimal here, you're going to get it wrong. That's like a 5th or 6th or 7th grade thing, right? And now I can add it up. 3 plus 0, 7 plus 4, carry the 1, 2 plus 1. Oh, I almost messed that up. Is this between 1 and 10? Yes. So now I can copy that down for my final answer. 3.13, times 10 to the 6th. Okay, I'm going to stop right there, guys. That is about as hard as they can do it when they are rude and they give you one in standard form and one in scientific notation. It would work the same way with subtracting, but I'm going to pause it right here. And if you have any questions, feel free to email me or leave a comment in this video, and I'll be more than happy to get back with you and help you out. So, one more time, guys. Here it is. The exponents have to match before you can add and subtract them. If you decide to move one exponent bigger, you need to take the decimal that goes along with it and move it one spot smaller. Or if it's 2 bigger, move it down 2. If this is up 3, move this down 3. If you take one exponent and make it smaller, then the decimal that goes with it needs to get bigger. And that was about it. Okay, I'm going to pause it right here. I'm going to upload this video, and then I will get you guys in the next one. We'll see ya.